Hello. Hello.
Yes, sir.
Okay. So let's start the class. What we have discussed in the last class? Ayush Kumar? Anyone just tell me what we have discussed in the last class?
Single phase transformer.
Single phase transformer, operating principle, EMF induced, and construction of the transformer. Last class also we just explained about the impedance transformation. So just to recap all those things, impedance transformation, how we can transfer the one side impedance, that means primary side to secondary side or secondary side to primary side. So just allow some students are in waiting room. We continue. So today we are going to discuss about impedance transformation of the primary side to secondary side, or maybe secondary side to primary side, and another parameter just like voltage, current, how we can transfer from one side to another side. So just share the screen. Okay, so some numerical problem and impedance transformation. So how we can transfer the impedance? Just as to see the systematic diagram of the transformer, how we can represent in electrical quantity of primary side and secondary side. Yeah. Yeah. So this is the primary side parameters, and this one is your secondary side. So EMF induced is represented by E1, and whatever the current flowing in the primary winding, that is represented by I1. This is your representation for the supply voltage, and similarly for the secondary side, the secondary coil. This is N1 and N2 represent number of turns of the primary and secondary coil. EMF induced, that is represented by E1 and E2 in the primary and secondary coil, and the supply voltage in the primary side represented by V1, and current flowing in the primary winding is represented by I1, and in the secondary winding represented by I2. Okay. So these are the basic electrical quantity mentioned here in the primary coil as well as for the secondary coil. Okay. Now, if you want to transfer the impedance from secondary side to primary side, what are the secondary side impedance that is represented by J2 if you want to transfer towards the primary side. Okay. So just how you can transfer, just see here. We already mentioned there impedance transformation, that is represented by Z2 total impedance of the secondary referred to the primary side. Okay. So just write here. Relation we already derived in the previous class for the ideal transformer. Okay. So what was the relation for the ideal transformer turns ratio? Anyone? Just tell me. Just tell me. Relation of the turns ratio for the ideal transformer. V1 by V2 equal to E1 by E2 equal to N1 by N2 equal to K. Is it not? V1 by V2, that means primary volt supplied to the transformer to the secondary side. So this impedance transformation we already discussed in the previous class. So just today recap all those things. I think picture was not clear. That's why I again try to show here clear figure. Okay. So voltage transformation, if you want to transfer the voltage, I just try to write here some.
Okay, this is the say heat exchanger or the it is the heater only. And then this
Problem
is
here,
main
that
product.
means
Then we have to control the product temperature. Okay, so in this way we can control total cascade control system. There is a two loop. First loop is the primary loop, which is controlled is small range and a particular part, and the secondary loop which is controlling the overall control system. So this type of control system is called cascade control. Okay. Second picture, you can say this is the primary it is taken. Okay, this is our primary. We are taking the temperature of this, and then we also in the secondary cases we are considering the heater or it will be done by your steam flow. Okay.
okay. Point number one was that if you want to transfer the
control the secondary also. So this is our
voltage of the primary side to the secondary side or secondary side to primary side, that is direct turns ratio. If you multiply, if you want to represent the V2 along the primary side, okay. So the voltage, just have you remembered the previous equation or the impedance transformer? That means Z2 dash divided by Z2 equal to K square. K square is nothing but turns ratio. That means N1 by N2 ka whole square. So Z2 dash represent as the secondary side impedance transferred to the primary side. Okay. Similarly, if you want to transfer the voltage current, then how you can just find out. So voltage
control total process.
are transferred in the
So in this primary loop,
transform
one small control system is going through, which is the primary.
in the direct ratio of
the
turns
accessory part, which is
in the
with the total process. Then this type of control system
direct
is called your cascade control system. Now we will go for
ratio of turns.
boiler diagram. Okay, you have seen in slide there is a typical boiler diagram is there. Now we are going for the details of it.
So direct turns ratio means what is the value of direct turns ratio? Just tell me, anyone.
This is your feed water setting.
Hello.
This is your feed water setting.
टर्न्स रेशियो क्या था?
Water normal.
प्रीवियस क्लास में कोई था नहीं क्या? हेलो. Deepak, are you present in the previous class? Hello.
Say this is a furnace or burner. Actually, boilers and we have there is so many type of configuration, but generally we are divided into the two types. For this case, that is a water tube boiler and a fire tube boiler. Okay, just for your with the convenience, in a fire tube boiler, what happens? Say this is your total boiler. 1/3 of the water
Then
content.
one student who is respond.
1/3. Okay, and 2/3 is empty.
The number of turns on its secondary divided by the number of turns on the
But
its primary.
not showing that 2/3%.
Okay.
2/3% is empty. Why this? Because
Turns ratio.
another 1/3%
You have to write here
is
reverse one.
T.
That means you are telling that is secondary to primary number of turns.
And
Okay.
another 1/3%.
But if you recall the previous equation, that means
1/3%
V1 by V1 equal to E1 by E2 equal to N1 by N2.
1/3.
That means N1 represents the number of turns of the primary coil
So in this way,
to number of turns of the secondary side. Okay, N2. That means direct turns ratio is your N1 by N2, that is represented by K. Okay. So if you want to represent secondary side voltage, that is V2, you represented by V2 towards the primary side. So how we can represent that one? Means multiply by the turns ratio. That voltage V2 multiplied by turns ratio. Okay. So V2 dash is equivalent to the voltage of the secondary side transferred towards the primary side. So that's why I have written here voltage are transferred in the direct ratio. That means N1 by N2 into V2 equal to V2 dash. That is nothing but voltage of the secondary side is equivalent to the voltage of the secondary side. Okay. Either you may be right here in the mathematical equation or maybe in a statement. Second one is your, if you want to represent the current. Okay. If you want to represent the secondary side current, that means I2 towards the primary side. So that current I2 represented by I2 dash. Okay. And that is equivalent to nothing but a product of the current of the secondary side into the inverse ratio of the turns. That means direct ratio is represented by N1 by N2 equal to K. Then what is the value of indirect ratio. That means 1 by K is not.
Here this is
Or you maybe say that
drum.
N2 by N1.
Mud drum. And
So
this
the current are transformed, that means I2 current
is steam drum and another drum.
are transformed in the
So whenever you fire on this steam will be this. This
transform
area is totally fire. This is furnace. Fire is going on, fire is going on. So
in the inverse ratio of turns.
steamer
In
gathers
the
over here, and these things are again it is
inverse
heated. That is what superheater. Then again it is
ratio of
to the
turns.
turbine. In this way it is working. And
Inverse ratio of turns means, that means 1 by K into I2. If you multiply by I2, then you will get the equivalent current
come to over
of the secondary side transferred towards the
water
primary side. Okay.
became
That
full,
means
it will come to
whatever the quantity of the secondary side transferred towards the primary side, that is represented by
and
either
this steamer
V2 prime
okay, in
for
this
both the
way,
voltage
what
or
is the
I2
polarity
prime
one?
for the current.
So
Okay.
here we are generally working
Without prime is your actual quantity of the secondary side, and in suffix 1 and 2 represent for the, as we already discussed in the previous class. That means, so whatever the standard quantity 1 and 2, V1 and V2 is your respective voltage and current quantity along the primary and secondary side. Okay. So if that actual quantity, if you transfer from either side, that means secondary side or maybe primary side. So just tell me, this value current are transformed in the reverse ratio of the turns. That means I2 dash equal to I2 into 1 by K or 1 by K. That means you may put their value of K, that means N1 by N2. So if you simplify this equation, you will get the I2 dash equal to I2 into N2 by N1. Okay. So you have to keep mind in this equation, all these equation for solving the numerical.
So what happens? Here is some control is there.
And one more point you have to keep in your mind. That means
control this temperature. What are the required temperature over there? And second one,
voltage amperes of two sides are equal. That means power rating. That means KVA rating of the transformer. Whatever the mention on the nameplate, that is both sides for the primary as well as secondary are equal. Okay. So volt ampere.
Then we just cut this fuel and air ratio such a way so that our requirement
Volt amperes of two sides, that means primary and secondary are equal. So what is the voltage? Volt ampere rating of the primary side.
This temperature is controlling as per your.
What is the value of volt ampere of the primary side?
Then this temperature also down. And if we just control this fuel and air,
just tell me,
or supply of fuel, then also the temperature will be varying. So there is a two control system are working. First one,
what is the volt ampere value of the primary side?
And the temperature control. Second one is the fuel control. If we require high pressure of this steam, then we just increase of this fuel and air. And if we have seen that is.
What is the volt ampere value of the primary side?
This heat water is coming very high. Then 80% is not work properly. Then we have to increase is 100% fuel ratio. If it happens that it is opening 80%, but feed water is very less, then what happens? This all water become steam.
प्राइमरी साइड में वोल्टेज किससे रिप्रेजेंट करते हैं? V1 से.
Say that is 50%. So that what are the available water? Then we can.
And current value is represented by I1. So what is the volt ampere rating of the primary side?
There is the two things are working at a time. This is called cascade. But in previous classes you have seen there is a two loop, but this is a parallel loop. But here you can see One by
If
one.
primary side voltage and current
represented
represented by V1 and I1. So volt ampere rating of the primary side is your V1 into I1. Similarly, for the secondary side, voltage and current represented by V2 and I2. So what is the volt ampere rating of the secondary side? V2 into I2. Is it not?
We are going for the control strategy. How it
Hello?
is working on. First, from this diagram, you can understand this thing. Look. This is your process.
Hello?
Yes, sir.
Just tell me what is the volt ampere rating of the primary side?
So V1, I1.
Final control.
V1 into I1 and secondary side V2 into I2. Okay. So you may be write this equation equal V1 into I1 equal to V2 into I2. So that you maybe find out any one quantity if you remember this relation. That means suppose that V1 you have given and I2 you have given and I1 you have to provide it. So you maybe find out the V2. Okay. So this point, that means volt ampere of two sides are equal. That means V1 and I1 equal to V2 and I2. Equal. Okay. And last point is your impedance are transformed in the proportion in the square of the turns ratio. That means Z2 dash is equivalent of the secondary side impedance towards the primary side. So that impedance you may be write as the square of the turns ratio, that means N1 by N2 whole square into Z2. Okay. So just write here in the point form, that means impedance can be transformed
Okay, this is clearly. Okay, say the feed
by
water and the feed water controlling is doing here. But another loop is working here, that is given by the
multiply the actual impedance, that means Z2, actual impedance of the secondary side,
outer
actual
this is the feedback part.
impedance of the secondary side that means Z2 and a square of the turns ratio. A square of the turns ratio. Square of the turns ratio. Turns ratio. Okay. That means Z2 dash equal to Z2 into N1 by N2 whole square.
Here two loops are working This is feeder loop. This is for the primary loop. And
If you want to transfer the primary side impedance towards the secondary side, then it will be becomes Z1 into
first fuel
N2 by N1 whole square.
heat exchanger.
N2 by N1 whole square. You have to keep in your mind parameters which side you are want to transfer here. Suppose that you want to transfer secondary side, then you multiply by the N2 by N1 whole square. If you want to transfer primary side, then multiply by N1 by N2 whole square. Okay.
Etc. In your food production, where our hot water are
You have to keep in your mind.
steams are required.
Now, suppose that if you want to solve
Some small
one numerical problem, whatever we have discussed basic principal operation of the transformer and impedance transformation of the transformer. Based on that, you just try to solve one numerical problem. So, suppose that question
if this is a 5 tons, type of
number one,
became 200 tons capacity. Okay.
Find the cross-sectional area of the core of a 10 tons transformer. Find the cross-sectional area of the core.
But in this case, fire tube boiler, small
Cross-sectional
and we are doing for the steam exchange or fire exchange, whatever.
area of core.
Normal cases, on
Area of core.
there we are using a small boiler, that is 5 tons. But for power generation cases, we are applying this is 200 tons and just like this, not specific, but this ratio you can imagine. Okay, so here you can see this feed water,
Cross-sectional area of
and the temperature
core
is the first primary
of 10 tons
then we are also if we go for this
of a
ratio, this is one loop and this loop also here, this is called outer loop,
10 tons
for the secondary loop.
for a voltage of 50 volt at 50 hertz.
These cascade control systems are working. You can realize this thing
For a voltage
and this temperature. Actually, this temperature is a ratio
voltage of 10 volt, 50 volt, 50
this is
volt
our prime things. And if we
at 50 hertz.
vary this well also, then it will also be affected. So you can see
50 hertz.
this process is step. This is our prime things. But if we change this ratio,
Find the
first
flux
we are
density.
applying,
50%
50%,
and the core area, that means the flux density of the
then we are applying
core.
90% of fuel injection.
The-
Then it will must change, because if I give some heat, much heat, first time heat is temperature T1 degree, then temperature is greater than. Second time temperature is T2, third time temperature is T3. Then the steam generation must be high. First time that is P1, second time P2, third time P3.
The flux density is 0.9 Weber per meter square.
Outer loop.
The
And
flux
in this case, you can see
density
steam water is changing. The first
Density
steam water is W1, then steam production
is 0.9 Weber per meter square.
that is P1 dash. If that is feed water is W2, then steam
0.9
production will be also the P2. So if first
Weber.
is W1, then W2, then W3, that is the feed water, then what happens? Then temperature also vary. So we have to make this
Weber.
simultaneously, that is feed water and the
Per meter
temperature
square.
and the fuel ratio for the temperature, maintaining the temperature. That is input temperature, and this temperature is feed water temperature is the output temperature. So if we want to mix the position for the steam, we need minimum 150 centigrade.
So how you can solve this problem?
This temperature, then look, there is a two temperature is required.
The E is ERMS is equal to 4 F and BM into A by this formula.
Boiler temperature, it may be more high.
ERMS equal to
more than
2.44 F and BM into A.
state of temperature is required. So we have to
जस्ट पुट करो उसमें वैल्यू पुट करो कितना आ रहा है
these two temperature at
कौन कौन सा पैरामीटर दिया हुआ है पहले उसको नोट कर लो
sorry, this is the water temperature and the outside of this boiler where the
कौन सा पैरामीटर दिया हुआ है प्रॉब्लम है
section is called the furnace or the combustion chamber. Rather it is called combustion chamber because furnace temperature is much high where the irons and the
कौन सा पैरामीटर दिया हुआ है
going to heat. And this is called the combustion chamber and this is the
Number of tons दिया हुआ है सर.
नंबर ऑफ टर्न्स दिया हुआ है सबसे पहले नोट कर लो नंबर ऑफ टर्न्स
so these two temperatures are controlled over here. Look, this
equal to
must some ratio.
how much
If this is
10.
not controlled,
next
then if you control only this, then it is not fulfill your requirement.
और क्या दिया हुआ है
And boiler section
Voltage sir.
steam
Voltage.
Yes,
supply voltage
if you generate more steam, then what happens? Boiler may be cracked or your
Supply
safety valve may be
voltage.
broken, then it will go outside. Okay, so you have to make it such
that
a
is
way
equal to
as
also
per your
EMF
requirement.
induced that means E
That much you have
Okay.
to generate. Otherwise,
EMF.
it may causes this fatal
Induced
or
EMF.
It may causes just loss.
you can say that
Okay, so here
induced
these two loops are working. This type of thing
EMF.
is called cascade control loop. So guys, if you
कितना दिया हुआ है वैल्यू इसको नोट करो
just some specification and features of these things. Okay.
50 volt.
Look, if we look at the total control system,
50 volt ना
control diagram,
50 volt next another parameters just note down
process 2. Process 2. Or it is called secondary. Okay. And this process 1.
और कौन सा पैरामीटर दिया हुआ है
Flux density.
flux density just flux density equal to 0.9 और कोई पैरामीटर्स any other parameters given in problem except number of turns supply voltage and flux
The
density
frequency.
equal to 50 hertz
You can put this type at over, you can put this type in overall. Okay, this thing is.
so just put on the equation whatever is the EMF induced equation and which quantity you have to find out which quantity you have to find out
Sir, area.
area that is core area that is represented by capital A suppose that okay. Now just put on the equation EMF induced equation whatever we have tried in the previous class
But
and find out the
So 0.025,
area of
0.025 meter square.
if you put all these quantity in the induced EMF equation, then you will get the value of area equal to, that means A equal to
one manipulated variable, but
EMF induced, that means 50, and in denominator part you have to put all the quantity, that means 4.44
for the primary loop, this is primary loop, this is the secondary loop.
4.44
So 2 measurement is there, but one output is one
into frequency, that means
okay.
50 the value into number of turns, that is nothing but 10
the output
into flux density.
of the master
So into flux density, that means 0.9. Okay. So if you solve this equation, you will get the value of almost equal to 0.025 meter square.
you can see this is the master process, or it may not be
Meter square.
as per your requirement. Then you can see this is the master, this is the slave. The output of this master controller is the input of this slave controller.
किसी को प्रॉब्लम है इसमें बिल्कुल में? Anyone have problem in this numerical? How we can approach them? Just simple equation. Whatever you have to drive for EMF induced equation, put on that equation whatever parameters given in the numerical and find out unknown quantity. Okay. So you may be solve few more problems for the practice purpose, more frequently. Okay. These are the one example for that. You may find out another parameters in another numerical. Suppose that EMF induced you have to find out. Then just put all the parameters. Suppose that we are provided to you either cross-sectional area or maybe you have to given.
If there is a normal fixed ratio, the feed water is 10%.
Flux is already given, number of turns provided to you, and
we are just controlling
frequency of the supply voltage. Okay.
No problem.
So in this way you may find out those
but here this is
another parameters.
because first one this is 10%,
Problem.
then this is 20%, again this is 10%.
Suppose that one problem I have to left for your practice purpose. That's
feed forward control system. We are also applying some.
you try to just solve in the home.
As per
Here
our
200.
As per our rule base. But here, if
200
because we don't know how much
kVA
is coming. Sometimes it is 10%.
single phase transformer.
Sometimes it is 30%. So varying. So this is called disturbance. So for this disturbance, we are directly applying
Single phase
cascade control system
transformer.
Very effectively. In your feed forward control system, only one loop is there. There are some disturbance.